So let's do a few examples of rounding. And we know that if the digit after the digit that we are rounding off to, we know if it's less than 5, then we round down. And if the digit after the thing that we are rounding off to is a 5 or bigger, 5, 6, 7, 8, 9, then we know that we round up. So here we go. Let's round 0.4257 to 1 decimal place. Well, there's 1 decimal place right here. So we want to cut off the number there, basically. So we want to cut it off with 1 decimal place. If you look just to the right of that decimal place, we end up with a 2. That's smaller than a 5. And so we'll round down. All of these things will become zeros. And because they're at the end of a decimal number, I don't need to write those zeros down. It's sufficient just to say 0.4 to be rounded to 1 decimal place. Alright, here's another number. Let's round this to 2 decimal places. So here's 2 decimal places, 9, 3, it's 2. Now if I look to the right, this 8 is now 5 or greater. It's bigger than a 5, so that means that we have to round up. So this 3 will now round up to a 4, giving us 13.94. And then everything else afterwards reverts to zeros. And of course, I don't need to write zeros at the end of a number if they occur after the decimal point. Alright, how about the next one? We want to round this one to 3 decimal places. This is a little bit tricky, however, because it's been given to us in scientific notation. So let's first change it into regular notation. It's 10 to the power of negative 1. It's a negative integer in the exponent, and so we want to look for a very small number. That means we need to move the decimal to the left. But we only need to move it to the left by 1 place. And so you can imagine then that we're going to end up with 0.759841. And now let's round it to 3 decimal places. So there's my 3 decimal places. If I look to the right, I have something that's bigger than a 5, so I must increase the 9 by 1. Now wait a second, I can't put in a 10 into a single spot. So I look at the 59 and I'll increase it by 1 to a 60. It's kind of like if you're thinking about the mileage on a car, and you're 9, or if you're 8, let's look up here, sorry. If you're 3 increases by 1, it just rolls to a 4, no problem. But if your 9 on a car odometer increases by 1, and it rolls over back to a 0, and this one also rolls over by 1. In other words, the 59 becomes a 60. And so we end up then with 0.760. And I know you must be thinking, oh, but this 0 at the end we shouldn't have at the end of a decimal number. Yes, we should. We need to demonstrate that we have 3 decimal places. When we had 1 decimal place, there it is, 1 decimal place, 2 decimal places, 2 decimal places, 3 decimal places, 3 decimal places, and that 0 is that 3rd critical decimal place. Alright, let's round now. 1,651 to the nearest 10. The 10's digit is right here, so that's where we want to cut off the number. If we look a little bit to the right of that line, we see that we've got a 1. That's smaller than a 5, so that rounds down to a 0. And here we do need to write that 0, because it's occurring before the decimal point. And we do need to show zeros at the end of a number if they come before a decimal point. Or we would need to show zeros at the end of a number if they are one of the critical decimal places that we're rounding to. Alright, I don't actually need to draw this decimal point. It's implicit that it's there. This number, I guess because it's been given in scientific notation, before we round, why don't we convert it into regular notation? Times 10 to the power of 3, we're moving the decimal 3 places, and because it's a positive 3, we'll move in the positive direction on a number line to make a larger number. 1, 2, 3. And that's going to give us the number 5,010. Now, if I want to round to the nearest 1,000, that means I'm cutting it off after the thousands digit, and the number to the right is smaller than a 5, which means I'll round down, so all of these become zeros afterwards. And that is the nearest 1,000. Instead of rounding then to decimal places, what if we were rounding to n significant figures? A lot like with the decimal places, we will look at the digit just to the right. So if we've got n significant figures, we'll look at the digit one over to the right, the n plus 1th digit. So you imagine if we had 5 significant figures, we would, to round, want to look at the 5 plus 1, the 6th digit, the one immediately to the right. As before, if we have 0, 1, 2, 3, or 4, we will not change the digit that was in the nth spot. But if we have bigger than 5, then we need to increase the nth digit by 1. And like before, we'll then get rid of all figures after that nth digit, replacing them by zeros if necessary. So let's try this. We'll round 0.4257 to 3 significant figures. Significant figures, much like in scientific notation, we need to look from left to right for the first non-zero digit. So that's a 0, it doesn't count. There's the first non-zero digit. Now we're going to start counting. 1, 2, 3. Those are the 3 significant figures. We are cutting it off there. Because the 7 to the right of our third significant figure, because that 7 is bigger than a 5, we need to round up. So this 5 will become a 6, and we have 0.426. Look, 3 significant figures, 1, 2, 3. Our first non-zero digit, and then we count 1, 2, 3. Done. Let's do the next example. We'll round 13.9386 to 2 significant figures. So let's look at the number from left to right, looking for the first non-zero digit. As we count it, oh look, 1, that's our first non-zero digit. So 2 significant figures, there they are, the 1 and the 3. We're going to cut it off right here. The number immediately to the right of my second significant figure is a 9. That means that we're going to round up. The 3 will round up to a 4, and we're left with 14. Look, 2 significant figures, 1, 2. Let's round this one now to 4 significant figures. Because it's been given in scientific notation, it will be best to change it back into regular notation. The -1 we know moves our decimal 1 to the left, so we got 0.75981. And now we want to round to 4 significant figures. So as we count from left to right, this is a 0. It doesn't count as a significant figure. Here's our first non-zero digit, the 7. So 1, 2, 3, 4 significant figures. That's where we'll draw the line. And the number to the right is smaller than 5, and so this will stay as an 8. And everything afterwards will basically disappear, unless it's necessary to write it, but in this case it isn't. 7, 5, 9, 8. That's 4 significant figures. And then the 1 afterwards has disappeared as a 0. And lastly, let's change this one back into, we did this already, right? We know it's 5010. And we want to round it to 1 significant figure. So as we count across looking for our first non-zero digit, well, we hit it right at the beginning, a 5. 1 significant figure, we'll cut it off there, and the 0 on the right-hand side of that cutoff is below a 5, meaning that we are not going to change the 5, and everything afterwards would revert to zeros. We do have to write these zeros down because they occur before the decimal point. The zeros at the end of this number, that when we rounded our 1 down to a 0, we didn't need to write that number because we've already got our 4 significant figures. And if we included an additional 0, that would be a 5th significant figure because it occurs at the end of a number after the decimal. We'd have 75980. Now, one thing that it's difficult to work out is when you're looking at a regular number, how many significant figures has it been rounded to? We actually don't know. It's possible, you see, that this has been rounded to 1 significant figure, like we did in this problem. But if we rounded this number to 2 significant figures and the cutoff was here, this 1 is still not enough to move this 0 up to a 1, and so we'd have 50, doesn't change, and then everything afterwards would come down to a 0. We still have 5,000. We can't tell if this has been rounded to 1 significant figure, 2 significant figures, 3 significant figures. It could even have been rounded to 4 significant figures if you had something like this. So we count 1, 2, 3, 4. There's the cutoff. This is smaller than a 0, smaller than a 5, I'm sorry. So it rounds down to a 0, disappears because it's after the decimal point at the end of a number. So you cannot look at a number and you cannot know how many significant figures it has been rounded to. But you can take a number that hasn't yet been rounded, and you can round it to any number of significant figures or decimal places, depending on the question. Now, the IB convention is to always round to 3 significant figures, unless you've been told otherwise. So, when you're writing a quiz, test, or exam, always give your final answers as exact values, so exactly, or rounded to 3 significant figures. Of course, unless you are instructed to do something else. Okay? Last batch of examples. We're going to use a calculator to evaluate these, and we'll give our answers in scientific notation. So let's do the first one. 0.4569 times there's 6 zeros, 0.1, 2, 3, 4, 5, 6 zeros, and then 3993. And lucky for us, the calculator gives it to us in scientific notation. We're just going to have to change. Oh, did I not specify that you were supposed to round to 3 significant figures? I'm sorry, I should have done that in this question. That's my fault. I also want you to round to 3 significant figures. So as we write down scientific notation, 1, 8, the 2, and what comes after the 2 is a 4. That's less than a 5, so I don't need to change my 2. So 3 significant figures, and now I can go times 10 to the power of, and my calculator says that the exponent is a -7. Oops, sorry. 10 to the power of -7. Part B, 385. Oops. Times 1,250. And that gives us a big number, and now we're dividing it by 0. And now 5 zeros, 6, 7. And that gives us, oh, lucky again that the calculator gave it already in scientific notation. Let's round to 3 significant figures. 7 is my first significant figure. 7.18. And if I look after that third significant figure, it's less than 5. So I round down, and I have 7.18. And my calculator says I've got a +10 as an exponent. You might notice in scientific notation then, when we round to 3 significant figures, we always end up with literally 3 digits. The first one is a number between 1 and 9, and the entire number, in fact, is between 1 and 9.99. Alright, part C. We've got 1,250 squared times 650 raised to the power of 3. If I want to get a raised to the power of 3, I can use this hat button to the power of 3. And that gives us 4.29. And that's been rounded correctly to 3 significant figures to the power of 14. Part D. In order to get the square root, I need to do second function x squared. And now I can put in the number 0.0000782. That gives us 0.00. Let me write it out to the side. 0.00884,307. Okay, that's far enough. Now, if I want to change into scientific notation, I know that I need to have my first non-zero digit. That's where I need to move the decimal. So I need to move it 3 places to the right. And that means that my exponent is going to be a 3. Because this is a very small number, it's going to be to the power of -3. And now that my decimal place is in the right location, let's go 1, 2, 3 significant figures, and the number to the right is less than 5, so we cut it off at 8.84. There we go.